Hey, let's talk about graphing an absolute value equation in the plane. So we haven't talked about these in class yet, but they're very similar to our quadratic equation when it's in vertex form. So the vertex of this equation is going to be here. That's going to be where your x is, and it's going to be -5. It's going to be the opposite of what you're looking at. And then the y value is going to be here, and it's going to be exactly what you see. So when we get our graph, we're going to find that point at -5 and -4. And that's going to be where the vertex is. Then we're basically going to have a V shape. Absolute value graphs always make a V shape. We could talk about why that is a little bit, but I'll try to make this brief for you. The next thing you're going to need to do to be exact is to come up with some values that belong on the graph. So since I already know the vertex is at -5 and -4, I might want to look for a value of x that's maybe -4 or something close by to that -5. If I plug in the -4 here, what I'm going to get is 4 times the absolute value of -4 plus 5 minus 4. -4 plus 5 in the absolute value signs here is a 1. So we have 4 times 1, which is 4, minus 4, which is 0. So if I didn't make a math error here, I'm going to have a point at -4 and 0 right there. And if this is true, I'm going to have a mirrored value right here, but I'm just going to double check my math by plugging in a -6, because see, everything is going to be just like the quadratic equations. The parabolas have an axis of symmetry. The absolute value functions with their V shape also have an axis of symmetry that goes down the middle. So I'm going to plug in this -6. I'm going to do 4 times the absolute value of -6 plus 5 minus 4. -6 plus 5 is a -1, but the absolute value signs mean that I'm going to take that out as a 1, right? Even though it was a -1, it becomes positive because it's in the absolute value signs. 4 times 1 is 4, and 4 minus 4 is 0, so that's cool. It means I have another x-intercept right there. That may be enough for Alex. You're going to have then a graph that looks something like this. If you should need more values, then you could keep going. You could move over to -3, and you could plug that in. You would say 4 times the absolute value of -3 plus 5 minus 4. -3 plus 5 is actually a +2. The absolute value of +2 is just 2. So 4 times 2 is 8, and 8 minus 4 is 4. So at -3 here, I actually have +4. It's going up 1, 2, 3, 4. So you can see that my graph is going to keep going through that. I could plug in a -7 to go further out on the left, and I would have 4 times the absolute value of -7 plus 5 minus 4. This makes a -2 inside the absolute value signs. -7 plus 5 is -2, but the absolute value of -2 is just 2. And then I'm going to do 4 times 2 is 8, and 8 minus 4 is 4. And so that's a good sign. I'm going to have this other value that's mirrored exactly across here. And I could keep going. These will be a lot like our parabola is mirrored on either side. The absolute value graph is always a V shape. It sort of hits its vertex and bounces up on two sides of an axis of symmetry like that. Hope that's helpful.